So esters are made up from a reaction of either a carboxylic acid or a carboxylic acid derivative with alcohol to make an ester. Now for the reactions of the esters. There are some reactions of esters that you are responsible for, not all of them. The first one is hydrolysis, meaning that you take the ester, you add water to it in presence of an acid. So what's going to happen? What's going to happen here is that the ester bond will be broken. So this ester bond here, it's going to be broken, and the ester will lose the OR group on it. And then the hydrogen from the water will also be lost. These two will be combined and you're going to get an alcohol. And the part of the ester will turn into a carboxylic acid. Every time you do hydrolysis with carboxylic acid derivatives, your product is going to be back to the carboxylic acid because you are adding in water. So all what you're doing, you're replacing the OR with the OH. This is what you are doing, okay? So in order to write down the reaction, make it simple in there, I'm going to break the ester bond, okay? And see that OR bond, I'm just going to replace it with the OH. So my product in this case is going to be a CH3, a carbon double bond O, and the O, and then the benzene. This, I'm going to substitute it with the OH. So we're going to add the OH in here. Plus, of course, you have a byproduct, which is whatever was lost from the ester here. You're going to go ahead and combine it with the hydrogen of the water. Okay, so this hydrogen here is here. And then this part of the ester is here. And all what you did is simply you replaced, okay? You replaced the OR of the ester with the OH of the water. And your product is called a carboxylic acid in this case. And of course, your byproduct is the alcohol. Okay? So hydrolysis of esters always gives you a carboxylic acid because you're using water. So it's the OH of the water that is going to substitute any OR group on the ester. So the key thing is to go ahead and break down the ester bond. This is your reaction site. And you're going to substitute that OR with the OH group in there. And group everything together. So that is going to be a carbonyl. This is going to be replaced by the OH plus now my separate product. I do have my hydrogen here that will be connected to the OR, and I'm going to end up getting my byproduct in this case. Make sure that you draw your byproduct right. Take into consideration every single carbon. So here now I have my alcohol and I have my carboxylic acid. Okay. This is one type of ester reaction where you are doing hydrolysis, you are reacting the ester in presence of water. Another type, which is very, very, very useful and very important, is the process of how to make soap. Okay, and we call this reaction saponification. And it also starts with an ester. But now what I am doing is I am using a base in the reaction, okay? So the base is a must for the saponification. Base is a must. See the difference? Up there was hydrolysis. I was using water. So I ended up getting a carboxylic acid. My medium is acidic, so I'm fine. I got my carboxylic acid in there. The acid survives in the acidic medium. Here, my medium is base. So my product that I'm going to form has to be a base. Pay attention to that. This reaction is a process how to make soap, and the texture of the soap and the properties change by changing the ion that you are working with. So if you're using sodium in the base, so if you use sodium hydroxide, then you get solid soap. And if you use potassium hydroxide, then your soap is going to be liquid. So you can change actually the properties of the salt by changing the base that you are using. But whether you're using sodium hydroxide or potassium hydroxide, both are bases, okay? So let's go ahead and do the general reaction in there. And in this general reaction, what I am doing is, again, I am always breaking my ester bond, And what I'm going to form is I'm going to replace the OR by the OH as usual, okay? But that is not going to be my final product because I cannot have an acid in a basic medium. So that is going to be my OH in there, plus whatever is left, which is the OR prime, that this one is negative. That is going to balance with the sodium in there. Please check the formal charge table. When oxygen has one bond, it's a negative charge, okay? So that is a base in here. So I'm forming a base, guys. And that base is strong enough to come and take that acidic hydrogen. So the reaction is not done until my final product is a carboxylic acid salt, which is soap. So the reaction goes again in there. So let's go ahead and write another arrow in here. This means now these two are going to react with each other. And the base is going to take a hydrogen. So that base is going to come and it's going to take a hydrogen from the acid. What acid? It's going to take a hydrogen from here, from this acid there, because this hydrogen cannot stay in a basic medium. It has to be removed. So the base takes that hydrogen in there and it creates a salt in this case. So you have your negative charge that is balanced with the sodium, plus of course whatever the base took. This is the R prime OH in here, which is your alcohol. And that will be my final product. And this final product is a carboxylic acid salt. Okay, and that is what we call soap. It's a soap molecule in there. Let's have an example. So you're using here sodium hydroxide. I know that I am going to break that ester bond in there, and you don't have to do the two steps, okay? So I would go ahead, I know that this OR will be replaced by the OH, but the medium is basic. So now I'm going to take the hydrogen out and I'm going to be left just with the oxygen, and you can put your right charges in there. So I will have a carbonyl that will be connected to the O negative in there, and then you put your charges, you balance your charges with the counter ion, plus of course I would end up having this is a CH3, okay? It's a CH3O. I'm going to add a hydrogen to it, so it's going to be a CH3OH. We're going to do the same thing. We are going to break this CO carbonyl bond. My product is going to be a phenyl, and that phenyl is connected to the carbonyl. All what you need to do is just add an oxygen, put a negative charge in there, balance it with any counter ion you have in the solution. Here I do have it as a sodium. In the other one I had it as potassium. So you're going to balance it with the potassium, plus of course the leftover of the ester. You're just going to bond it with the hydrogen of the base. And that is going to be an O. Here you go. And then a hydrogen in there. And this is going to be, you don't have to write the lone pairs, but normally I like to write them. But you don't have to show those lone pairs in there. And that is going to be my alcohol byproduct. So you get your carboxylic acid salt. This is potassium benzoate. And that is sodium ethanoate. Okay, we can call it also sodium acetate if we want to go by the common name, but all of those are considered to be salts. This is why I am starting by naming the positive counter ion first. So summary of the reactions in there, if you want to go over the summary, you can have this in the exam as well. So you have your carboxylic acid, two reactions we talked about in carboxylic acids. You can react carboxylic acid with a base. This is acid-base reaction, and you get your carboxylate salt. Or you can simply react the carboxylic acid with a weak base. So this is a strong base, this is a weak base in there. And then that is going to be a dissociation. You get your conjugate acid and the conjugate base. So it really depends on how strong your base is. So you go by either a strong base or you go by a weak base. Okay? Now, if you want to go ahead and react your acid with the alcohol, then you're going to make an ester. And with esters, they do undergo hydrolysis in presence of an acidic medium and a basic medium. So if you hydrolyze the acid in presence of an acidic medium, then in this case, you're going to get the carboxylic acid and the alcohol. If you hydrolyze it in presence of a basic medium, that process is called saponification. And you are going to get the carboxylate, salt, and an alcohol. The process by which you go from a carboxylic acid to the ester is called esterification. Okay. Also, which is not found in this table, the other processes that we talked about for esterification, that you can start with a carboxylic acid or carboxylic acid derivatives. So I'm just going to put here or carboxylic acid derivatives, and those, when I react them with an alcohol, they will give me ester as well. So carboxylic acid salts that have very long arc chain. There are different types of carboxylic acid salts. You have carboxylic acid salts that are small. They have small arc chain in there, as these. These are used as food preservatives. They are not used as soap. For carboxylic acid salts that can be used as soap, to be soap molecule, you need to have a very long arc chain. And that arc chain has to be more than 12 carbons. So more than 12 carbons, we can consider the molecule to be a soap molecule in there. If you want to go ahead and name this soap molecule, because you can see that it is made up of 18 carbons here, then the name is going to be, it's soap, right? So I'm going to start with the sodium. So that is going to be sodium in there. And I am naming this as IUPAC. Okay, and it is 18 carbons, so dec is 10 and oct is 8, so that is going to be octa, decan, 08. And the common name, it's sodium stearate. It's fine, you don't have to go by the common, but you should be able to name the IUPAC. This is a chain of 8 carbons, and of course 18 carbons, I'm sorry, and of course you have to start numbering from carbon number 1. So as a summary, when you're looking at carboxylic acid salts are two types, either small or big molecules. The big molecules, they are more than 12 carbons and they act as a soap. The small ones are used in food preservatives.